bi-weekly contest of 158. Question number 1. Maximize y sum by picking a triplet of distinct x values. So what is the question? Let's go to the whiteboard and let's analyze this. Cool. So we had given a two integer array with the same size, and we had given that x array and the y array. So what we need to return, we need to find a triplet, and how we are supposed to find that triplet. So we need to find the triplet such that the sum of triplet should be maximum, and the corresponding value for that triplet in x should be distinct. That's the question statement here. Okay, cool. So here as we had given, so we had given x and y, so we need to find the triplet. So first thing what we're gonna do, we'll try to find out, okay, we'll greedily we'll go for the maximum 3 element. So we'll go for a 5, then 4 and 6, correct? Yeah, correct. Let's check it out, the corresponding x element for it. So it's a 1, for 4 it's again 1, and for 6 it's 3. So now we had a collision here, as you can clearly see. For the x, the 1 is again coming. So what we need to do, we need to remove any of them, either 5 or either 4, as we had to maximize the final amount. So we'll remove this 4, and instead of 4 we'll pick up the next greater element, which is 3 in our case. So we'll pick the 3, and now the corresponding x is 2 here. Now we had satisfied the condition which is asked in the question statement. So now let's do the summation. So 6 plus 3 is 9, and 9 plus 5 is 14, which is expected here. Cool. Okay. So given the problem statement, the brute force which we can think is to generate all the subset of length 3. Cool. So we'll generate all the subset of length 3, and by after generating all the subset, we'll manually check the distance property, and also will maintain one uh, like a result kind of a variable which store the maximum value encounter so far. Okay. Yeah, but the implementation of this problem is similar to the combination sums in the backtracking which we had seen. So this will, like, you had to generate okay, so we had a 3 spot to fill in, right? 1, 2 and 3. Cool. And we had a n candidate for this. So it should be nc3, right? So to generating this itself, it will take order of n cube, like if you do the summation and all. So let's not go over that, but the clearly the uh, constraint has been saying that it's 10 to the power 5, so backtracking approach wouldn't work. So we need to go for the optimized solutions. Okay, so how can we optimize the solution? So okay, so as we had done one things here, that we'll remove the 4 and we'll take the next maximum element. So that's why the priority queue which we can think about it. So what we can do, will, like, the so approach which we can towards go is, we'll put all the element of the y in our priority queue and take the next top 3 elements and do the summation. But that will not work because we need to check the distinct property as well. So that means in the priority queue itself, we need to store the corresponding x value for that, and while we generating our answer, we'll check the corresponding x value, and if it is the same, we'll pop it out and we'll search for the next value. Okay, so I'll show you the code. it's just a basic implementation problem, I would feel. So here is a Java code. I had make a pair here which will store the value and limit. So value is nothing but your y array, and limit is nothing but your x array. Okay, so this priority queue, as we are we are trying to take a maximum value, so here I had generated the max heap. This is our max heap, and I'll put all this element in our max heap. So this set is for checking that we had encountered the three pair three values, and we are good to go with our answer. And here you can clearly see I'll take the value from the priority queue, and if the x value, which is in our case it's a limit, if it is already present in the set, that means we are the collision, as we had seen here 1 and 1. So what we'll do, we'll not take in our answer, and we'll move forward for the next iteration. And as soon as we'll encounter the 3, we'll return the sum. And if we haven't encountered at line number 35, it is expected that we need to return -1 here, so we are returning -1. Let's try to submit it out. Okay, and discussing the time complexity here, it's clearly order of n log n, because here we are inserting the value in and using the priority here. And regarding the space complexity, it would be the order of n, as we are using a priority queue. Okay, thank you.